Okay, fourth question. It says dealing out 10 cards. What is the probability of having at most 9 even number of cards? So we can start with 0, but we can have at the most 10. So if I can find out probability of getting 10 even cards and I can subtract that 1, it would have at least 1 card including 0. So probability of getting 10 even cards when you are not replacing it. So if I assume that there are 20 even cards out of 52, which is 5 in each color, it's 20 over 52 to the power 10. Probability of getting up to or at most 9 even card is 1 max probability of getting all even. Let's look at what would happen if you don't do replacement in the same question. Once you get an even card, the number of even card decreases and the sample also increases. So here you are multiplying all of these things. So when you multiply all of these things, the probability becomes even lesser because you have less chances of getting an even because you have reduced one even. So if you observed here, each point in time it was 0.38, but here it reduces because if you go down, you have 43 cards but just one even left. So this is even smaller. So the probability of getting if you replace it, you have got still more chances of getting at most one even card, but if you don't replace, then the probability of getting up to 9 even card is more higher because this is 9.99998 and this is 9.986. So this is a very rare case because it would reduce. So this probability is small and this is higher. When I move to the other question, it says that half of the customers register at these two things. What is the probability that the customer saves $20 by using one of these coupons? So uh, we have to find out two probabilities and see what $20 mean. So if I observe this carefully, half of the customers register buys $50 and other half by $200. So for the first half, this is 10%, and we know that getting a discount greater than 10% or $20 for 20 is 50%, which is this color. This is for the first one, and this is for the second one, which is the sum of greater than 20, because 20 for 50 is to save 20% would be for a 50 should be greater than 40, sorry. So greater than 40, which is uh, this thing, which is 3.13125. And since they have given to us that 50% people goes here and 50% goes there, I can make a sum of 50% and I can divide that by half. So which is like 26%. So since they are telling us that half of the customers, what is the probability that the customer saves more than 20 by using one of these coupons? So we have reduced this probability to half. So you can look at it that we have 50% of chances that we are going to save this much. We have 50% of chance that we are going to save greater than 40, which is very less. So the total answer becomes less. In 1D, I think this is a little complicated, not very positive, but it's a question of conditional probability. It says that given that it happened in 6 days, what is the probability that it took more days? So for these types of question, we have an equation which says that P of A and B is probability of A and P of B given that A has already happened. So in this question, we want to find out this probability that what is the probability that it took more than 4 days, but that probability given that A has already happened. So that would be probability of A and B, which is the intersection of both divided by probability of A. So if I go back to the question, the probability of machine coming less than 16 and more than 4, so that is the intersection point. We just calculated it in C and we divide that by 0.7, so we are using this formula.